Hello students, let's discuss about carbenes today. Carbenes are one type of intermediates. Carbenes are generally having two bonds and two electrons. It will be given like this. Here two bonds means two each, four electrons which are coming from two bonds, and two electrons, these are again two. So total number of electrons are 6. When electrons are less than 8 electrons, 8 electron system as we call octet system, 6 electrons is definitely electron deficient. So number of electrons are less than 8. So electron deficient system. Carbenes are again very unstable, very short lived. These carbenes are again of two types. These are important for you. The first one is we'll discuss singlet carbene. Singlet carbene meaning is it's very simple. When you are taking the 2s plus 1 value, this is called spin multiplicity. This 2s plus 1 value is equal to 1. When this is equals to 1, this is called singlet carbene. How it is equals to 1? So spin multiplicity is given by 2s plus 1, where s is total spin. Fine, s is total spin. Let's have a look at this. Carbon atomic number is 6. Electronic configuration will be helium 2s2 2p2. This is 2s2 2p2 configuration, right? In this, carbon 6 will show 2s1 2p3 configuration. This is in excited state, you can say. This is excited state configuration. Because of these 4 electrons only, it is forming 4 bonds. Now what happens in singlet carbene is, we are discussing about the singlet. In this, now you see the 3 orbitals. One electron is here, second electron is here, third and fourth electrons are together here. This forms a bond. I am writing little bit lengthy electron here. This means these are forming bonds with some other atoms. Let's say hydrogens. So they are forming bonds. Now these two electrons are present here. These two electrons are present in same orbit. So the first electron, if you take the spin as plus of, for the second electron the spin will be minus of. Plus of and minus of, the overall spin will become 0. The total spin of these two electrons, don't worry about these two electrons. This electron and this electron, they are participating in bonding. So we are discussing only about these two electrons. The first electron plus of, second electron is minus of. So overall spin is equals to 0. Now, as we said, the formula is 2s plus 1, where s is total spin. Total spin, as we discussed, that is 0. So this total is equals to 1. Because of this, it is called singlet carbene. So now here the hybridization will be sp2. sp2 means it should be planar triangle, but one lone pair is there, as we are discussing. Because of the lone pair, the geometry will be bent, or you say angular or bent geometry. How it will be? You can take 1 2 3. This is trigonal planar. One electron, 2 electrons. These are forming bonds with some other atoms. Let's consider hydrogen. This will be the pair. This you can show like this. You see, carbon having 2 bonds, maybe hydrogens, chlorines, whatever you want, you can take. The 2 electrons are present in the same orbital. Because of these 2 electrons same present, no unpaired electrons are there. So this is diamagnetic. Unpaired electrons are not there, so diamagnetic. As we were discussing singlet carbene, these are less stable. when it is less stable, you can say the reason for this is that is lone pair of electrons, so it is less stable, and when this is less stable it is called hot carbene. So singlet carbene is called hot carbene. Fine. Now let's go with triplet carbene. Triplet carbene means 2s plus 1 when you are taking this must be equal to 3, where again s is total spin of electrons. Let's see how it happens. Now carbon's electronic configuration, 2s orbital and 2p orbital I am taking. This is in general ground state electronic configuration as we were discussing just now. One electron jumps here, so the electronic configuration will be like this. This is excited state. Means excited state configuration, one electron, second electron, third electron and fourth electron, these are present here. These two are forming bonds. Okay, they form bonds, and the remaining two electrons are present in two different orbitals. So the first electron spin is plus of, the second electron spin is also plus of. So overall the spin will become, when two electrons are like this, I'm showing you again, these are forming bonds. This is plus half, this is also having plus half, so overall spin is equal to 1. Now 2s plus 1 formula, when s is equals to 1, 2 into 1 plus 1, this is equal to 3. This is only called triplet carbene. Fine. So in triplet carbene this is somewhat stable, so this is called cold carbene. Stable when you compare with the hot, stable than singlet. This is stable than singlet, so this is called a cold carbene. How the structure will be, it's interesting. There are two type of structures you can show. One is linear with 180 degrees angle. The remaining two you can show like this. The two orbitals, you can say these are the pure p orbitals of carbon. Pure p orbitals are having one unpaired electron, second unpaired electron. This is one type of geometry that you can show. Because of two unpaired electrons, it is paramagnetic. Or it can also show one bond, second bond, and a sp2 hybridization. One electron is here. These two are bonds, for example hydrogens, let's consider. And there will be a pure p orbital. This pure p orbital is also having one electron. So sp2 also you can take, this will be bent in shape because this electron is not participating, this is bent in shape, but one unpaired electron is in sp2, another electron is in pure p orbital. Both you can consider, but in general when they are asking singlet and triplet, you consider singlet as sp2, triplet as sp. Okay, it can be even sp2 also, but in general if they are asking, that is sp. Singlet is hot carbene, that means less stable. This is cold carbene, so it is more stable. This is about the carbenes. How generally carbenes are formed? See one very interesting reaction. This is chloroform. When a base you are taking OH minus, for example, this will be attacking on this hydrogen. Show the arrows properly. This will be moving here, and this chlorine is out. OH minus attacking on hydrogen, so that is going out in the form of H2O. This electron pair is coming onto the carbon, that will be like a pair, and this chlorine is going with electrons, so Cl minus. These are removed, so you can show with minus sign, minus H2O because of this, minus Cl minus because of this. The remaining part is this one, that will be two chlorines and two electrons. This you can call dichlorocarbene, and this we are going to use in Remartin reaction. Dichlorocarbene is the intermediate. Similar way you can take many examples. CH2N2, diazomethane, if you take CH2 and N2, both are formed